Hello. I'm going to start. My name is Christian Campo. I'm the project lead of Riena. This talk is about Riena is an open source framework in Eclipse. It's part of the release train. I'm one of the committers and also the project lead. And Riena is on top of RCP, but it can also run on not only RCP 3x, but also 4x. So it can run on a wrap. And we're also working on making it run on using other toolkits. So this talk is about what we do in Riena to make that happen, how we have to do certain things to make it possible to work on these different environments. Who's heard of Riena before? Oh, great. Who has this problem also that they have to run on multiple platforms, like on RUB and RCP or something? Oh, OK, good. So I'm going to start to get everyone on board with just a little tiny thing on what is Riena for those people who have not seen it or heard it. And then I'm going to do all the different technology that Riena runs on and explain what we have to do to make that happen. Riena is, as I said, an Eclipse open source project. It's running on top of RCP. So from our viewpoint, RCP is not end user friendly. It's something that was built from the UI guidelines and from the way the RCP apps look like. It's more built with an IDE in mind. So Riena is, for our viewpoint, meant to be the end user version of an RCP application. So as you're going to see, we have a different kind of building UIs, which are more friendly for building business applications for end users. It's built on RCP, on Workbench, on OSGi, on JFace, on SWT. But it has a completely different look. What is also different, or as an add-on to RCP, is that it has a client and a server component. So we have remote services. You can place your components and your services on a client and on a server and seamless call them. Of course, calls to the server will take longer, but still, from the programming model, there'll be no difference. And so we have a Riena client and a Riena server component. And here is an example application that we have. That's what Riena, the example application from Riena, looks like. So as you can see, it does not look like this IDE stylish RCP application model, so it looks very different. The whole thing is called what we call from the semantics application. This thing on the top is sub-application, so you can partition your application into different pieces, like your custom application, your email application, something, if you want to have these two types of things in your application. And on the left side is this navigation module, where you play module groups, modules, and submodules, just as means for dividing your application into many, many different pieces that sort of interconnect. So the module groups, modules, and submodules. And then on the right side, that is the place where you actually put in forms and views, where your data is shown, where you play your logic, where you enter data, where you store them, where you start actions. So these are actually all RCP things. So the sub-applications are technically, they are perspectives. They just look very different. But technically, you have an RCP perspective for each sub-application. And technically, these are all RCP views. So we reuse a lot of the technology that is in RCP for making that happen. But still, we use the RCP things. The view where your logic is, where your forms are. In RCP, everything is in the view, and you bind your widgets directly to your model using JFace. In Riena, it's a little different because we use MVC, so we have a model that you also have in RCP, but we distinguish between view and controller. So in the view goes only the code that does the layout, the coloring, fonts, stuff like that. And the controller, you have the pure business logic. So I'm going to show you how that works, what we're going to do for that, but we separate them out. So that makes it easier for us to build controller because they're not filled with code for actually doing layout and fancy stuff. And for that, we built a whole navigation model. whole model of the whole application as it's running as a dynamic model that is, where pieces are added at runtime. So it's a very hierarchical model. On the top, you have the application that contains sub-applications. Each sub-application contains several module groups. They contain modules and submodules. So that's the technology stack that you get when you run Riena in RCP. So on the top, there is your application code. There is a code that you write that is programming against Riena APIs. Riena uses under the hood, uses JFace, it uses Workbench, and all this stuff. The application also uses a little bit of SWT to lay out your views and stuff. And on the bottom is the operating system, of course. SWT goes directly against Windows widgets, for example, or Mac widgets. Now, if you use wrap, you replace that bottom layer. So for the wrap, you replace that with RWT, with the widget toolkit that has the same API as SWT, but which is for the web. And you're also adding a client, which is a web browser that is then rendered in your browser. So then what also changes when you make that change from RCP to wrap is that previously with RCP, every user has its own JVM. Now, if you are in a web world, then you have this one JVM, and suddenly many users are working in this JVM. So that's a change. Yeah? If you just run your RCP applications with one user in wrap, then that always works. But as soon as there are multiple users, there are certain things you have to be aware of. This is the same application as you see in the web. So this is what it looks like if you render it. Looks very similar, not identical, but it looks similar. It also has the same kind of application model. You can also see that some parts are missing, like here the borders are missing. There are technical reasons for that. So I'm now going to talk about a little bit what it takes to bring it over. When you bring over an application from RCP to wrap, something that the wrap people always talk about is single sourcing. So what you want to keep as much as your source code is the same in RCP and wrap. You don't want to port your application to wrap and then it only runs in the web, but you want to run it in both worlds. So you want to keep the diff, the changes that you have to do, only run in RCP and in wrap, so minimum. Many things from the RCP API, from the Workbench API also exist in wrap. There are a few exceptions. One is mouse listener. Mouse listener is when you hover with your mouse over some elements, then you can track that in Java, in SWT. In the web, that's not possible because that would mean that every move of the mouse from the browser is transferred to the server. That is much too much expensive, so they left it out. The other thing is paintlessness. That's what we do the borders with. So we had the borders of the navigational thing with paintlessness, and you cannot paint in SWT with, if you have wrap with the SWT API. You always also don't get a graphic context. Whenever you paint something on the graphic context, what you can do in RCP, you cannot do that in wrap. So to sort of factor that out, these differences between RCP and wrap, we use facades. So we have, every time we sort of stumble over a certain difference between RCP and wrap, we build a facade, and then that facade takes care of calling the detecting, whether that's in RCP mode or wrap mode, and then it calls the RCP implementation or the wrap implementation. So for example, for the mouse listener, we have a facade, a mouse listener facade, and the mouse listener facade in RCP is going to actually have an implementation, and its wrap is empty because it's not sending any mouse events. And the same is true for paint listeners, for graphic context. Also, the dialog constants are a little bit different. And also, of course, browser is different. If you are in RCP, you can embed a browser widget and render something in there and bring in some HTML code in there. If you're in wrap, you can also do that, but you are already in a browser. So that's rather an iframe or a frame that you embed in your page. So it's a little different in the API. And the other thing is singletons. In your application, you would have singletons, and normally you just say, okay, this is this class, and I have just one instance of it. Now, if you come to this JVM that has multiple users, you have to distinguish between what we call global singletons and session singletons. There are singletons which are really singletons, like OSGi services are singletons. There's nothing we can do to make OSGi services per user. Yeah, that's the way Equinox works, or OSGi from the spec works. We cannot change it. The navigation model, which keeps a track of what sub-applications are open, what views are open, what the user is currently doing, that'd be really weird if that be a singleton. So that must be a singleton that is per user, a session singleton. So we have to change our code to make that happen, to also, again, use a class that distinguishes between the two. And that is a task that you have to do in a framework like Riena, but that's also a task that everyone who writes an application has to do. So if you write business code, maybe some of your components also keep state, and you have to make sure that if that's a singleton and it's only one instance, that if you move to the web world, then you have to, have it per user. We have an API for that, which is called Singleton Provider, which is very simple. In this case, I use a SWT view provider, something that gets me a view that's maybe already active. And I don't know, or I don't need to know whether I live in RCP or RAP. This thing, get instance, will always get me one instance. If I'm in RCP, it will always get me the same instance. If I'm in RAP, it will get me the instance of the session. There's a utility class in RAP, but the problem there is that you have to know whether you are in RCP or RAP. So we built a helper class that helps us to not know in our code which one. We don't have to, this functionality to know whether you're RCP or RAP has to be just in one position. So these are, I think, the two things. Facades for factoring out the pieces where our API difference between RCP and RAP, and the other thing is about the singletons. The next thing is about how do we run on Eclipse or E4. Because we use a lot of rendering because our application looks so different in RCP than RCP, we had to do some stuff. It's like here is the Rihanna client on top, and then underneath it is the navigation model. Then there is this Eclipse RCP, 3x RCP API, and we have some custom renderers. So what is in here is the presentation API, which allows you to change the way RCP is rendered. And there's also advisors, which is an API to allow you to hook in certain times in the life cycle to when the application is started, do some stuff. And then there's also this workbench API, like the platform UI and stuff like that. Okay. So when you come to E4, that is all gone. These APIs still exist, but they have no functionality. So we had code in our advisors, and you'll be shocked to see that they're no longer called. Also, the presentation API is still there. It still compiles, but it's not doing anything. You can try to do a presentation, but it doesn't even come up. So E4 is binary compatible, but it's not the functions. Some functions are really missing or empty in E4 intentionally. So E4 is cool. E4 has finally a good model. It has a modular design. It has a rendering engine, so you can, all pieces of your application model, decide how you want to render it, and it has a good life cycle. So we were not sure how we're going to deal with this difference. Now we have this navigation model from Riena. We have this application model, and I think there are two ways to attack that. One way would be to merge the two. Just forget about our Riena navigation model and just redo it in E4. E4 has this EMF editor, so I could just add an EMF model where I have application, sub-application, and all this stuff, and write renderers for that. That would work. We tried that. The other possibility is that we keep as much of the code as we already have and just synchronize the two models. So every time we add something to well, I'm going to show you. Yeah. So just synchronize the two models. So that's what we're doing. So that would be the Rihanna navigation model would talk to the renderers, and Eclipse 4 and this is an application model, they have all to sync. So the way it works is, here's E4, here's the model, the application model of E4. So when an event happens, that be like you click on a view or you click on a perspective, then that will trigger off an E4 event. That E4 event goes into the navigation model, and then the navigation model would sync with the application model and changes stuff like add a new view or activate a perspective or anything. So, and we did that. So now Rihanna runs on E4 and on E3, and the impact is very minimal. So we can run the same code, it's very small changes only to be able to run on these two platforms. If we had changed to just forget about our model, then it'd be nearly impossible to still run on Eclipse 3X platforms, because that'd be a very radical change. So E4 perspectives, they still exist. I mean, they're now optional in E4, but we still use them, and we use them for sub-applications as we used before. And E4 parts are now submodules. That's the part on the right side. You can use E4 views, or you can use 3X views and still show them in this work area. So the last part is JavaFX. JavaFX is this new cool thing that there are a number of talks on this conference. Just an arbitrary example of a JavaFX widget, which is this line chart, or this charts that are now in there. There are many new widgets, and I think there are many different ways to make your application work in JavaFX. I'm just going to name a few before I explain how we do it in Riena. SWT for me is this layer, this widget layer, which already has many implementations for Windows, for Mac, for Linux, but it also has implementations for different toolkits. So it has one for Swing. We did one for Qt, and I know that Tom Schindler is already working on one for JavaFX. So you could be just replacing the SWT that you have with the SWT that renders into JavaFX, and you don't have to change anything. I think the advantage is that you can rerun your applications that you already have. You can use the SWT API that you know. I think the disadvantage is that you have to use the SWT API that you already know, because you cannot use all the cool features that are new in JavaFX. Maybe you want to run or want to program against JavaFX, and you don't get that. There's a new toolkit I ran across, or a new library that I ran across a few weeks ago, which is Joe Widgets. It's very similar to SWT, only that they have sort of an abstraction layer like SWT. Every toolkit is a complete new re-implementation of SWT. With this Joe Widget library, they seem to have a few, they have a few abstraction layers on top. So they have this one API on top where you define, oh, this is a text widget, this is a text, this is a maximum length and stuff like that. And then underneath, somewhere here, they have service SPIs for plugging in the implementations for the different toolkits. And that way, you can also write applications that run multiple toolkits. There's also Eclipse Scout. They use more a modeled approach. So they model everything in property sheets. So they have endless property sheets where you say, oh, this text widget here, this length, it binds to this. And then at the end of the day, they generate code out of it. So that's another option. And I think they could also not, currently they can generate SWT, and they can generate wrap and swing. They might add something to do JavaFX. So the way we do it is, here's my example. We concentrated for the beginning, like this is the part that is controlled by the application programmer, while the rest is controlled by the navigation model. So here is an example where we replace that part on the right side with FX. So these are all FX widgets. The good thing about JavaFX is that you can embed JavaFX controls into SWT. So that's what we're currently doing just as a starter. So for the beginning, we just leaving the navigation model as it is, because that's very simple to replace with own renderers in JavaFX. But we want to save as much as possible the logic and code that are in the applications here, where the applications developers put their code. So FX Canvas is a thing you can embed into a SWT composite. And remember that I said that in the work area, we separate model, view, and controller. Here's how we do that. So here's a model, and we use data binding between the model and the widget that we keep in there. And here's the view. So what we do under the hoods is that the view has all the widgets. So it has a text widget, radio widget, table widget or something. And then when the view is instantiated, we look for all the widgets and create widgets. Widgets are something, Rihanna widgets, they are, you get one widget per widget that you have in your view. And widgets are, they are not toolkit dependent. They are independent, and the widget and the widget are bound together. So the widget we only use for putting in the layout information, colors and fonts and stuff. The widgets is for adding listeners, for doing setting texts, or for validation and stuff. We also put in more functionality in there. Widgets are rather very stupid. Widgets can do stuff like they can do validation and show a marker when something is wrong, so they can control the way the widget looks like, depending on content. And it's also very nice because the API is reduced. If you look at a SWT widget, you get this large list of API functions. Widgets are smaller because they don't have to deal with anything that's toolkit dependent, like layout and colors and fonts, but you rather concentrate in your controller only on the logic. So in this model, here's my SWT view, here's my controller, here's my model. So now if I want to put in JavaFX, I can just replace the view, you have to rewrite the view and rewrite it with JavaFX controls. And then underneath the controller, where it's all your logic and your business logic, stays the same. Because we just have to rewrite in Riena the widgets that are understanding JavaFX widgets. So I think that'd be our approach for maintaining as much of the code that are written by the application programmers. I have an example for that. Yeah, JavaFX. When we did that, we found a few glitches, like JavaFX doesn't use the Java Beans convention, but they also use the JavaFX Beans convention, which are different. So we had to add some code for that, for being able to bind between Beans and JavaFX Beans. But the styling capabilities are a lot better. So what we do for error marking, unlike RCP, where you get this control decoration, we rather put round red borders around the field. And you have many more, and that's really hard to do because you need a paint listener and stuff like that. With JavaFX, you can have round borders. You can really control a lot better how these things are rendered. It looks a lot nicer. And this is something we're currently still developing. We're not finished with that, but we have a number of widgets that we already translated, or a number of widgets that we already support JavaFX, and the rest is just a matter of doing it. So it's still in progress. Yeah. So I showed you a little bit about wrap, about E4, how we do that, and JavaFX. So that if you're interested in Riena, we have wiki pages, we have download pages, and of course a Git repository, get involved. And that's pretty much it. Any questions? There's just, I think we have for two bundles, you either add in an E4 bundle or an E3 bundle. I think the key point is you don't have to change your application. Your application does not notice whether you run on E3 or E4. There's no API changes in Riena. It's totally transparent to your program.
Okay, so this means there are customers who use Eclipse 3 and there are customers who use
Yeah. They can use both things. Any more questions? Okay. Please supply feedback, like with every talk. I will also say that for my talk, please have